everybody, and happy holidays. Today, I'm going to start my 5-part lesson on character rigging and rigging basics in Maya. So today's lesson will be in Maya rather than in Cinema 4D, as in my opinion, Maya has a better package for real in-depth character rigging over Cinema 4D. We're going to start with the torso today, both IK and FK rigging, and then move on to the arms and legs and head in another lesson. And then in the 5th part, we'll talk about the face and some methods for either using blend shapes or curves to rig the face. So without further ado, here we go. Alright guys, so here in Maya, I have my character already imported. It's just this guy that's made out of rocks. And right now he's a single piece of geometry. So what I'm going to do is to go into my component mode and select the faces and start removing these pieces of geometry from each other. So double click and then go to mesh and then separate. And then I'm going to hide everything but the torso because we're going to work on the torso today. And then for the next lessons, we'll work on the arms and legs and head. I'm going to rename this to Torso Geo. So the next thing I'm going to do is start making a joint chain that is along this entire torso, acting as the spine. I'm going to go into my side view, turn on X-ray, and then I'm going to create joints. So I'm going to go to my rigging, and then I'm going to go to my skeleton and click create joints. Create a joint chain that is pretty straight throughout this torso. All the way to the neck. And it's okay if they bend just a little, but you want to keep them as straight as possible. So you could do that by holding shift. And then if I want to reposition these joints, I could select the joint chain and clicking the insert key and then reposition. And then I'm going to want to make a proxy rig for this. Proxy rig is a temporary rig that we can use to see how our rig deforms and will be replaced with the actual geometry later on. So I'm going to split this torso up into different parts corresponding with my joints. So how I'm going to do that is to go to Mesh Tools and click on the multi-cut and then isolate my joint and cut right along the joint. Isolate the next joint, cut right along it, the next joint, and that'll split my torso into sections that I can use to bend the geometry. And don't worry right now if you have n-gons, because we're not going to use this as our final model. This is just the proxy rig. So next, I'm going to select the faces for each section of this torso and extract them. So go back to my component mode, select the section, extract. Select the next section, extract, and so on and so forth. So that should leave me with individual sections that correspond to where my joints are. And this is how the torso will bend according to our proxy model. And then I'm going to go into my outliner and delete the history for it. Edit, delete all by type history. And then I'm going to select my torso geo and select all of the geometry and organize it a little bit by moving it out of the groups. And then I'm going to rename each section and place them accordingly. So this would be torso, hip. And then I'm going to start renaming these joints. So I'll name this one hip, spine 1. So next, I'm going to have to line up all of my local rotation axes for all these joints. So if you notice, if I select these joints and then go to display and then go to transform display and click local rotation axes, my axes are all different. So these ones, the y-axis is facing towards the back, and this one on top, the z-axis is facing towards the front. So I'm going to want to go and transform those so all of my y-axes are facing the front. So I'm going to select the hip joint and all the spine joints, go into my rigging, and under skeleton, select orient joints and click the little checkbox. The controls here let you set the joint's local rotation axes. You have to orient this entire chain to the same axes so they all match. So what I'm going to do is make the secondary axis Z and X for my secondary axis world rotation. And then click apply. And that should line up our whole joint chain except for the top joint, which is fine because it is the end of our chain. We don't need that to be oriented to the same as the other joints. So I'm going to check to see if that all rotates accordingly by selecting the bottom joint all the way to the hip joint and then trying to rotate it. And that seems correct. And you can see that if I rotate it forward, it rotates forward on my z-axis, which is what I want. So now we're ready to create an IK handle. So what the IK handle does is it creates a control curve that we can manipulate in order to manipulate the joints of our spine. So we're going to do that first, and then we're going to create an FK handle to control the individual sections of our spine. So I'm going to go to my skeleton and select Create IK Spline Handle. And then I'm going to click on the hip joint, and then I'm going to click on the neck joint. And that should create a curve that is the length of my spine and an IK handle. And then I'm going to rename this Spine Handle and Spine Curve. And then you'll notice that we can't exactly manipulate this. So we have to go into component mode and then select the IK handle's control vertices. And then we can move that around to move the entire spine accordingly. Same for the bottom. But we're not going to be able to have the animator select the control curve every single time he wants to move the spine. So we're going to have to make joints that control these control vertices and then controllers to those joints. So what I'm going to do is to duplicate this entire chain and then delete everything but the hip joint and the spine 5 joint. So the very top and the very bottom and the effector. And that'll leave me with a joint in place for the very top of the spine and then the very bottom of the spine, exactly where my control curves are at for the spine curve. And then I'm going to rename these hip bind joint and then shoulder bind joint. And this will give me a basis for where to control from. Next, I'm going to select the shoulder bind joint, the hip bind joint, shift select, and then select the spine curve and go to skin and go to bind skin and click on the option box And then I'm going to go to bind to select the joints. And then the max influence I'm going to set to 2 since we only have 2 parts which we want it to be binded. And then click apply. So now when I move my hip joint, it's going to move that control curve. Same with the shoulder joint. Next, I'm going to go and parent my geometry to the appropriate spine joints. So for the torso hip, I'm going to click drag and bring it to the hip. Torso 1, click drag, bring to spine 1, and so on and so forth. And now you can see if I rotate these, my torso is going to rotate. So now that I have that figured out, I'm going to create a set of controls for these bind joints and constrain those controls to the joints. So I just have to move the controls instead of the joints. So how I'm going to create a control curve is I'm going to go to my create menu and create a cube. And move that cube's handle to exactly where my joint is. I'm going to go into my side view, hold down V, and snap it to that joint. And then I'm going to modify this curved shape to kind of look like how I want my controller to be. So I'm going to move the CVs out, and position them to some place that I can kind of use to control from. So outside of the geometry slightly. And this, by the way, is an easy way to create controllers. So I'm going to go to Create, Curve Tools, EP Curve Tool, and then go to Settings menu. And then under Curve Degree, I'm going to switch to Linear. And then the target, I'm going to select these control vertices and just click and move. And then we're going to hold down V and snap it to the point, and then move it around to the next point, and then the next point, and then the next point, and then back to the original point. Do this and trace around the entire box that we have. And don't worry about going over the same points again. It won't register them as new points. So keep holding V and trace this entire box. And then press enter. And then I'm going to hide this cube. And then I have a cube that is the control for my hip. And then I'm going to rename the curve hip control. And then I'm going to press insert and go to my side view and align this to my joint. And then press insert again. So now the center of rotation is exactly at where my joint is at. And then I'm going to make sure that my transformation is zeroed out. So it's zeroed out right now. That's good. And then go to edit, delete all by type, delete history. So that'll help me to bring my pivot to the center of that joint. And that's where I'm going to want it, because if I rotate this controller, it's going to rotate that joint. And then for the shoulders, I'm going to duplicate this controller, rename it shoulders control, and move it to the shoulders. And then I'm going to play around with the CVs so that they kind of look like some sort of shape that I would want my controller to be in and the positioning that I would want it to be in. And then I'm going to hit insert again and then snap that center of rotation to my joint by holding V. And then I'm going to freeze this rotation. So I'm going to go to modify and then freeze transformations and then delete history. So next I'm going to change the rotation orders for my controllers. So I'm going to go into attributes and change this to ZXY. And this will make sure that my y-axis is calculated after my z-axis. And this will help later for things to be rotating correctly. And then I'm going to change the rotation orders to ZXY on my hip bind joint and my shoulder bind joint as well. And next, I'm going to constrain these controllers to their bind joints. So I'm going to select my shoulder control and then control select my shoulder bind joint and then go to constrain and then parent. And then I'm going to do the same thing with my hip bind control and my hip bind joint. Go to constrain and parent. And then you see if I move these controllers, it's going to move my bind joint, thus moving my entire spine. So what we want when we animate is to set keyframes on solely the controls and not the joints or the curve at all. And certainly not the geometry. But the only problem right now is that the torso and the shoulders cannot twist. That's because we haven't activated the twist rotations yet. And this is going to be done by going into our attribute editor. I'm going to go into my spine handle and then enable this twist control and then set the world up type to object rotation up and set my world up object 1 and 2 to the hip bind joints and the shoulder bind joints. And I'm going to set this forward axis to -x. And I'm going to set these up vectors to -1 for the y-axis and then -1 for the z-axis on up vector 2. Then I'm going to set the up vector to -y. And this is because we are setting it to look at the last and first joints in the chain. So we're setting the forward vectors and up vectors to those joints. And now if I twist the controls, the hip twists along with it. And it's because I have to tell Maya to look at the last and first joints of the chain as reference for my vectors. So that's about it for my IK spline part. The next part is I'm going to attach a separate joint chain to my IK chain to allow it to control in FK. So that'll give me some more precise controls on how the spine chain bends. But basically I can't just move these joints and rotate them because they're already locked into place with my IK handle. So I need to make another chain. And this will give me more control over the minute bends of the spine. I'm going to go back to my side view and go to skeleton and create joints. And then I'm going to create another joint chain that is roughly around the size of my current joint chain, but with 3 different joints. And hold down V to snap to the last joint. And I'm going to press insert to kind of adjust some of these joints to line up with my spine a little bit more. And then I'm going to rename these joints to FK joints. So FK hip, FK spine 1. So the next thing we're going to do is make sure that these joint orientations are proper. So if I select all my joints and then go to display, transform display, and local rotation axes, and you can see that some of these y-axes are facing the back. And then I'm going to go to my skeleton and then go to orient joint and select that and see if it matches up with my joints from beforehand. And it does, and then I'm going to click orient. So all my y-axes are facing forward and my up axis is the x-axis. And then change this rotation order to YZX. So next I'm going to parent this chain to my control group. So I'm going to group these to themselves. So I'm going to click Control G and then name this shoulder constraint group. And then group the hip control to itself and name it hip constraint group. So I'm going to parent constrain my forward kinematic shoulder to my shoulder const group, and then my forward kinematic hip to my hip const group. And now you can see if I move this chain, it's going to move the controller that is my shoulder and also my hip too. So now all I have to do is to constrain these joints to controllers that control my middle portion of torso and then upper middle portion of torso. And I'll get more minute controls of this torso that way. So what I'm going to do is to make a NURBS circle. So we're going to create NURBS primitives circle, scale that up, and snap that to the joint. Hold down V, that should snap it to the joint. Duplicate it, snap it to the second joint. And that'll give me a point of control for this FK group. And then I'm going to freeze the transformations on these. Modify freeze transformations. So what I'm going to do to parent these is a little bit different. It's to not break the hierarchy of things later on. I'm going to select the controller and then go to display and then turn on shapes. And under the shape node, I'm going to shift select the appropriate joint. And then under my meld command menu, I'm going to type in parent -R -S. And that'll parent my shape node to that specific joint. And as you can see, it kind of moves this to another position. So all I have to do is select the CVs and rotate them 90 degrees and bring them back to the position where I want it. And that way, now when I rotate it, it'll rotate by constraint to the shape node. And I'm going to do things for the second joint in the same way. Select the shape node, select the appropriate joint, parent -R -S. And then move this controller back to the appropriate position. And there we go. It should be parented accordingly and move the forward kinematic of the controller appropriately. So the next problem I'm going to encounter is that when I stretch this, The torso is not going to stretch like how I would want it. You normally would want this torso to stretch out if I stretch the shoulder control. And there's a pretty easy way to do that, and that's by determining the length of this curve here and then determining what is being added onto it, so the percentage that it's being stretched. And I could do that with nodes in a simple equation using the divide node. So first I'm going to rename all these NURBS curves and clean up the scene a little bit more. And then I'm going to select the spine curve and open the node editor. So window, node editor. And then I'm going to click on the input output connections button to see the spline's node graph. So the main part I'm going to really be concerned about is the spline handle node and the spine curve shape. So I'm going to try to figure out the length of my spine curve. So I'm going to click tab and type curve info. Double click on it. And then I'm going to be concerned about this arc length. So right now it's at 0, but I want this arc length to display the length of my spine. So what I'm going to do that is I'm going to click on this little box here, and then under world space 0, I'm going to select that node and move it to the input node of the curve info. And then under other, I'm going to pipe it into the input curve. And now if I click on my curve info, I should be able to see the arc length, which is 71. So I'm going to remember that number. And that is the length of the spine in its resting position. So to check that, I'm just going to transform the shoulder control. Check on my curve info, and you see that it expands to accommodate for the stretch. So now we just need to find the percentage of increase of the arc length by taking the modified length and dividing it by its resting length, which is 71.237. So we can do this by using a multiply divide node. So press tab again, find multiply, divide, and double click on it. So the first input is going to be the arc length of the curve info node. So I'm going to pipe that into the input 1 and pipe that as x. And then the second input is going to be its resting length, which is 72.237. And then I'm going to change this to divide. So that'll divide the length that it modified to its resting length. And that'll give me the appropriate percentage. And now we can connect this number to our spine joints. So I'm going to select all of my spine joints, middle click, and move them to the graph. And then I'm going to connect each one of these to the multiply divide node. So I'm going to select the output of multiply divide node, go to output X is where I plugged in the operation, click on it, and hook that up to the scale X of each joint. Except for our last joint, which is oriented differently, and that is to Y. Scale Y. So now if I move it, you can see that everything scales accordingly and stretches out. However, the last thing that I'm missing is volume preservation. So when I stretch it, it stretches, but it doesn't squash like it's supposed to. So it's just one last step to add a little bit more realism to your character. Basically, when this torso stretches up in one axis, it should squash inward in the opposite axis. And we're going to be able to do this by inputting a standardized equation into the node editor. So go back to the node editor and create another multiply divide node. Hit tab. And connect the output of the other multiply divide node that you made. the X output into the multiply divide input 1 of the other node. And under the attribute editor, we're going to set the operation to power and put input 2 as 0.5. And I'm going to want to make the inverse of this, so I'm going to try to divide it by 1. So I'm going to create another multiply divide node. And plug the X output of the last node into the new node under input 2. And then set this operation to divide and the input 1 value to 1. And we're going to plug in the result of this to the Y and Z scale of all of these spine joints. So easy way to do this is to expand all these tabs and then plug into the X and Z that way. And remember to plug in differently for the last node to the X and Z value for the last one. So now you see that if I stretch this out, it's going to squash on the other side and preserve the shape. So finally, we're going to make a global controller for this entire torso. So I'm going to create a nerves curve, circle, snap that to my hip joint, and rename it body control. And then change this rotation order to ZXY. And then I'm going to select all the parts of the torso that we created and group them into a torso group, except for the body control. And then I'm going to parent constrain this group to the body control node. Constrain parent. And if you see right now, and if I move this global control, it's going to give me double transformations, which is because it is transforming twice the part of my arc length stretch node. So what I'm going to do is select the spine curve and turn off its inherent transform in the attribute editor right here. And now the curve won't be affected and we won't have double transforms. And then lastly, I'm going to create a control that controls the global scale. So I'm going to control select torso group and the body group and click Control G to group them. And this is going to be called the root. Then I'm going to change the rotation order to ZXY, just like the torso. So the problem is if I increase the scale of this root node, it also increases the scale of the spine curve. And therefore, based on what we did with the node editors beforehand, it increases the length of the spine. So that gives me a double transform on my torso. So what I want to do is feed a value into my root node that nullifies the double transformation. So I'm going to select the spine curve node again and open the node editor and create another multiply divide node. And rename that to global scale. Mult. And then feed the original curve info node that you had, the arc length, into input 1. And then 1x. Then middle drag your root group into the node editor. and feed the scale y of our root node into the input 2x of our multiply divide node. Set operation to divide, and then feed this into the input 1x of your original spine multiply divide node, replacing the current calculation. Now try scaling it from the root, and there we go. It should scale accordingly now. So I hope that was helpful, and tune in next time because I'll be doing the arms and the legs in a series, and we'll be learning more about how to rig a character. Thanks for watching and have a great day.